Everyone's section 7.4, and this is going to be general strategy for factoring polynomials. And so in this section, we're not going to see any new material. We're just going to take the 5 methods we've learned in the first 3 sections and then try to figure out how to tell them apart, and also just kind of review them to help separate them. And so I have this little flow chart here that I'll go through quickly, and then we'll use this. I'm going to review each of the methods, and then we'll use this to figure out what to do in which case. So step 1 for all these is going to be this factor out the GCF. So we're always looking to see if that's in the way. If so, we get that out of the way. And we saw that in section 7.1. Step 2 is we're going to count the number of terms. And this is basically what 7.4 is about. We're going to count the number of terms in the problem. We're either going to see 2, 3, or 4 terms. And then depending on if we have 2, 3, or 4 terms, we're going to do one of these things down here. So if we have 2 terms, if we have perfect squares on the ends and a minus, that's going to be our difference of squares. If we don't have that and we already factored out the GCF, it's done. That's as far as we can go. So for 2 terms, the only thing we have is difference of squares. If it happened to be 4 terms, great. That one's a grouping. That one's really easy to tell too. There's only one answer to that question. So 2 terms and 4 terms are pretty easy because there's only one possible thing to do. 3 terms, that's where it's a little bit trickier. So with 3 terms, again, GCF first. If the leading coefficient is a 1, that's great. That means we're in section 7.2, and that's where we do the what multiplies to the end and adds to the middle, and we set it up, x plus the thing, x plus the thing, and we put the numbers in it. They could be minuses as well. If we look at the ends of so let's say it's not a 1, and then we look at the ends and there's perfect squares in the coefficients, we are very likely in 7.3, and we're able to use those special product or special factoring formulas for factoring. And then if we look at the problem and it doesn't lead with a 1 and it doesn't have squares on the ends, then that means we're doing either magic or AC method that we saw in 7.2. So the 3-term ones are the ones that are a little bit trickier. 2 terms, difference of squares. 4 terms, grouping. 3 terms is where we have to do a little bit of work to get those squared away in our head. So let me show you some examples. And for these first 5, I'm going to go through them in the order in which we encountered them. So this first one is going to be a 7.1. It's got 4 terms, and so that makes it a grouping problem. There is no common factor, I can tell because of the 9 and the 2, so right there that's not going to work. And I do the thing where I cover up these 2 terms, and I figure what's the most I can pull out of there. So that's 27 and 9 would let me pull out a 9, a, b, and bx, so I can pull out a b. So 9 goes into 27 3 times, and it's going to leave behind that a right there. And then again, I always kind of multiply those back and go 27b, a, yeah, 27ab, cool, and just check myself. And then here we're taking out the 9 and the b, so that's going to leave the x behind. Out of these 2, it looks like, well, remember we have to get this 3a minus x again. So if I write that out, it helps me see that it's going to be a 2, and not only that, it's going to be a negative 2, because I need this to come back to negative 6a, so there's that. I need this to come back to positive 2x, so negative and negative would make that positive. And then this right here, that becomes my greatest common factor. We pull that out front, and there's what's left. So that's pretty much every 4-term problem right there. This next one, so again, our first step for any factoring problem is to see if there's a GCF. And in this case, there's definitely a GCF. There's a 3x squared going on in there. So let's get a 3x squared out front, and then we can see what we actually have. Until you get the GCF out of the way, other than the number of terms, you don't actually know where you are on this list. So 3x squared comes out, leaving x squared. 3 goes into 42 14 times. And then x squared out of x cubed leaves x, and 3 into 135 would be 45. So this is one of the friendlier kind out of 7.2, where the leading coefficient is 1. So we just do what multiplies to be 45 and adds to be 14. So 3x squared, x and x. So it multiplies to 45, adds to 14, sounds like 5 and 9, both positives because all my signs are positives. So for number 3, I look at this and I go, for a second I think 2's, and then I see that 11 in the middle, so that does not factor. There is no factors, but there's no greatest common factor. And then 6 and 10 are not perfect squares. So that means we're down here where we're either going to use AC or magic. I think on this one, I will do magic. Maybe I'll do AC on the next one. No, I did magic on the next one too because I like that one better. So I'll do magic, but you could do AC if you prefer. So 6 times -10 would be -60. And then we're looking for two numbers that multiply to be -60. And then since that's a negative, remember they're going to be, we would think of them as being 11 apart because of the way the signs are going to work. So if I go through my, what goes into 60, 1 and 60, 2 and 30, 3 and 20, so that's 17 apart, I'm getting closer. 4 and 15, those are 11 apart, so that's a good one. So my numbers are going to be 4 and 15, and the big number takes the sign in the middle, so 15 is going to be positive and 4 will be negative. Writing out my 6x and then -4, and then we do that extra 6 in there, but we'll divide it out in just a second, plus 15. And then we're going to divide out what would be the common factors, so 6 and 4, common to that would be 2, and then 6 and 15 common to that would be 3. 2 into 6 goes 3x minus 2, and 3 into 6 goes 2x plus 5. Oh, and then notice also, so I did 2 here, 3 here, so 2 times 3 is the 6, and that is that extra 6 I need to get out of there. For example 4 is the one that you don't want to do this way because this way isn't that fun. In example 4, you look and there's those perfect squares on the end, so then you're just like, oh, sweet, it's going to go 7x plus 2, quantity squared, and done. So that's where those formulas really come in handy, is when you do run into these, it's actually a really easy problem. And if you don't notice, then you suffer and you end up doing it this way, which is what you don't want to do. Okay, and then number 5 here, this one has 2 terms. So either it's just going to be a GCF or it's going to turn into a difference of squares. If I take out the GCF, I could do a 3x, it looks like, out of both, and I get x squared minus 25y squared. And then from there, we can see that is our, come back here, our 2 terms and our difference of squares. So a squared minus b squared, a plus b, a minus b. So this will be 3x, x plus 5y, and then x minus 5y. And then next I'm going to do 5 more problems. And they're just kind of all mixed together, so this is just using this thing to tell them apart. So that was sort of the order in which we saw them, and now we'll just run into them as we do. So this first one, I look at it, I go, okay, 49, so that's 7 times 7. 7 does not go into 36, so there is no GCF, but I am noting that it has 3 terms with squares on the ends, so I bet the answer is 6x plus, 6x minus 7 quantity squared. And then to check myself, just to make sure it's what it looks like, I could do 6 times 7 is 42, double it, and there's the 84. So that was much easier than doing AC or magic. This next one, so we got 1, 2, 3 terms, leads with a 1, cool, that means it's this kind. I just set up my x's, and I say what multiplies to be positive 21 and adds to be negative 10. So minus 3 and minus 7, and that's it, it's done. For number 8, 3 terms again, it does not lead with 1, it does not have squares on the ends, so that means I'm either left with magic or AC. So here I want to go 11 times 5 is 55, and then we're looking for 2 numbers that multiply to be 55 and add to be negative 56. So those are the 2 easy, it's hard, it's negative 1 and negative 55. And so then we can do this either by magic or AC. I should probably do AC just to show that one as well. So let's go minus 55x minus x plus 5. And so from these first 2 terms, I could factor an 11x, leaving me an x minus 5. And then out of these next 2, I need another x minus 5. So I would have to take out a negative 1. And then bringing that out front would give me x minus 5, 11x minus 1. Yeah, I really do not like that as much. If I did it the other way, I'm just going to do it the other way because So if I did it the other way, I would have had 11x minus 1, 11x minus 55, and then I would have divided out the 11 right there, and there's my 11x minus 1, and then that would have been x minus 5. I really feel like, I think this is like harder to learn. It's a little bit confusing, but once you get it, I do think the math is easier. Anyhow, this next one we got two terms, so it's probably gonna be a difference of squares. Looks like we could do a 2 and an x out of there, leaving a 4x squared minus 49. And you just have to be careful when you have that greatest common factor, especially on the test. Don't stop there. It's gonna keep going from there. So this would be 2x and then 2x plus 7 and 2x minus 7, or a plus b, a minus b. And then our last one has 4 terms, so the only thing that could be is a grouping. Let me rewrite it up here a little bit bigger. And so I got a and a, b plus 8x is what would be left there. When I take the a out, I would have that b and then 8x. And then I know I need another b plus 8x. So I'm going to take out, it looks like I need to do negative 10. And then I just double check myself right there and I'm good. So b plus 8x and then a minus